तर कन्फर्म माहित
नाही,
नाहीये
दोन
कोणाला
जणांनी
घेतलंय.
2 जणांनी ऍडमिशन घेतलेले नव्हते. तुम्हाला जे सांगितले होते त्या 19 मधले गेल्या वर्षीतले 2 जण फक्त म्हणजे राहिलेले होते. तिघांची नाव होते, त्यातल्या एकाने घेतलेलं आहे. म्हणजे याचा अर्थ 2 जणांनी घेतलं नसावं. तर ते आपल्याला चेक करावं लागेल. तर ते
ठीक आहे सर, तरी
2 जर
सांगतो आम्ही
गेले, 19
ग्रुपवर
मधले 2
मेसेज
गेले तर
करतो.
17. तर 17 विद्यार्थ्यांपैकी हा मेसेज कर आत्ताही लगेच. जॉईन इमिजिएटली आणि एक्झाम कंपल्सरी असल्यामुळं उरलेले जे काही 3 जण आहेत, म्हणजे आता लेक्चरला 13 जण दिसत आहेत, तर जे काही 4 विद्यार्थी अजून नाही आहेत, तर आपल्या ग्रुपवर तुम्ही टाकून द्या की कोण जे 4 विद्यार्थी जॉईन नाही झाले त्यांनी जॉईन करा. कारण लिंक जी आहे ही ऍक्च्युली ही पहिलीच वेळ आहे. ह्यामध्ये जर काही डिफिकल्टीज येतील तेव्हा तुम्ही मला फोन करा. मी कॉलेजमध्ये असणारच आहे. आणि माझ्याकडे ती आली लिंक की मी लगेच तुम्हाला शेअर करेल. तर व्हॉट्सअप ग्रुपवर आपला जो आहे त्याच्यावरती येईल. त्यामुळे सर्वांनी आपलं कनेक्शन आणि हे व्यवस्थित ठेवायचं आहे. त्या ठिकाणी 10 मिनिटच असणार आहे आणि 10 MCQ आहेत. हार्डली 5 मिनिटं मोर दॅन सफिशियंट होतात. तर त्या ठिकाणी तुम्ही ते एक्झाम देऊ शकता. ठीक आहे. मला त्या सर्वांचे डाऊट्स क्लिअर झाले का?
येस सर.
हा बोला, कोणाचे काय डाऊट्स आहेत का? Okay, so we can start with our regular lecture. And again, if you have any doubt, so for rest of 5 minutes of the lecture, then I will ask again. So as we have started the different ion sources, different types of ionizations, and on that, on last lecture, we have seen the electron spin induction. That is very, very important. And today we will see the, can you see the PPT?
Yes, sir.
Yes or no?
Sir. Yes, sir.
Very important. And nowadays this ion source along with detector, because in last lecture also I have said that the name of mass spectrometer is based upon which ion source is used and which detector is used. So on that basis they have given the name. So mostly MALDI TOF that we have mentioned on last lecture. So MALDI is nothing but it is the matrix assisted laser desorption. Here, this matrix assisted laser desorption technique in mass spectroscopy for ionization of large molecules, mostly biomolecules, polymers, synthetic polymers, for more fragile or form fragments when ionized by conventional method. So mostly for protein method is used. Mostly it is similar to electron spray ionization technique, which is both for softness and ion produced. In this case, this is very important. Ionization is triggered by laser beam. So such kind of questions are asked in MCQ. Even though in bits, comparison is asked. Which ion sources are used or ionization is triggered by which material. So such kind of questions are always there. So consequently, the high uh, throughput and speed association with complete atomization has made, and MALDI TOF mass spectrometer an obvious choice for proteomic work on large scale. So that is nothing but this MALDI TOF. When you will take the mass spectrum of any compound, then on the left hand corner upper side you will observe the name of instrument on which the spectrum have been taken. So mostly MALDI TOF is there. Then ESI and EI, these three are commonly used in multi-rate analysis.
Hello, sir.
And we already discussed that
Sir,
in 2002. Huh?
आनंद सुतार
Hello.
सर मीटिंगला त्याला जॉईन करा की सर, ऍड करा.
अरे इथे तो पुढे येत नाही ना नाव त्याचं, तर कसं करणार त्याला लिंक पाठवून कारण इथे शेअरिंग थांबून करावं लागेल का? तो एकटाच आहे का मीटिंगला?
सर त्याचा एकट्याचाच मेसेज आला सर मला तरी.
अरे रे, कारण मग मला हे शेअरिंग बहुतेक स्टॉप करावं लागेल, कारण इथे थोडीशी एकटी अडचण आहे. मी आता गेल्यानंतर ते ऑटोचं एक सॉफ्टवेअर आहे, ते थोडंसं मी ऍप जे आहे ते डाउनलोड करून घेणार आहे, कारण ऑटो अटेंडन्स आणि ऑटो जर झालं, कारण मग मला आता हे स्टॉप करावं लागेल, कारण इथं तो ऑप्शन येत नाहीये. म्हणजे पूर्वी जसं झूमवर आपण लेक्चर चालू असताना जर कोण ऍडमिट होत असेल ना, तर तो वरती येतो तिथे. तसं गुगल मीटला येत नाही. त्यामुळे काय होतं की ते एकदा लेक्चर सुरू झालं की मग कसं त्याला घ्यायचा. मग त्याला ती लिंक शेअर करून जमेल का का नाही? बरं ठीक आहे, अजून एक दोन जर कोण आले तर
जमेल
मला
ना.
सांग, मग मला हे थांबावं लागेल मग.
ओके सर.
जर अजून कोण असतील, एखाद दुसरा आलेला असेल ना तिथे वेटिंगसाठी, तर मला सांगा, मग आपण हे स्टॉप करू शेअरिंग आणि त्यांना ऍडमिट करून घेऊ आणि परत शेअरिंग चालू करूया.
ओके सर.
जस्ट आय विल चेक वेदर. मी आता स्टॉप करतो, पाहतो काय होतंय का. दिसतंय का तुम्हाला आता?
सर रेकॉर्डिंग चालू आहे.
पीपीटी
नाही
दिसते?
सर, नाही दिसत.
नो सर.
नाही सर, नाही दिसत. पीपीटी नाही
नाही
हॅलो,
दिसत.
सर, दिसत नाही.
हा,
नो.
नो सर.
येस ऑर नो? हा, मग ते मी आता तिथे
नो सर.
स्टॉप केली. एक मिनिट. ठीक आहे, अजून कोणी ऍडमिट होणार? एकटाच होतं का आता? एक नाव होतं इथे,
हो
कारण मला
सर,
परत
तेच
शेअर
होतं.
करावं लागेल. झालं का तो सुतार? विचार त्याला लवकर.
हा सर, विचार.
आ,
हा सर, झाला तो जॉईन.
हो सर, झाला झाला जॉईन झालं.
okay, so today I will take that two apps download, so it is better way to auto admit and okay. Can you see now? Can you see PPT? Yes or no?
येस सर.
Okay,
Yes,
so
sir.
in 2002, Nobel Prize in Chemistry was awarded to the Koichi Tanaka of Japan for the development of soft distortion ionization method, that is MALDI, for the mass spectrometric analysis of biomolecule, that is the macromolecules. And this is the sharing Nobel Prize for ESI as well as MALDI. That is very important discovery for the determination of molecular weight of polymer or large molecules, macromolecules. Now, when we see the principle of this MALDI, the sample for analysis of MALDI MS is prepared by mixing or coating with solution of energy absorbent. We can call it as matrix. So similar to that, here also we have to take matrix, that is the organic compound, and we have to dissolve or mix the sample, and that is form a uniform layer on the uh, plate. So when matrix crystallize on drying, so once we are dry, so after coating of this solution, and when we can dry it, it can form a crystallize. So as this matrix is crystallized and already the sample is along with that, so the sample in trapped within this matrix is also co-crystallized. And after co-crystallization, desorption is triggered by UV laser beam. So we remember that here we can use UV laser beam directly to trigger this desorption. So matrix material heavily absorb this UV laser light, leading to the ablation of the upper layer of the matrix material, and hot plum get produced during this ablation. And here the analyte molecule is undergo ionization in this hot plump. The ablation species may participate in the ionization of analyte. So this initially this UV laser beam, when it is triggered, or when it can pass on this sample holding material or plate on which we have already kept the sample along with matrix in a crystallized form, and then this matrix material absorb these UV rays, and then they can be converted to their ion form. And here just we can see how the matrix and sample get prepared. So generally matrix consists of organic compounds, that is crystalline molecules. So commonly used are nothing but 3,5-dimethoxy 4-hydroxycinnamic acid, that is synapinic acid, it is also commonly called. Then alpha cyano 4-hydroxycinnamic acid and 2,5-dihydroxybenzoic acid, DHB. So these are the three commonly used organic compounds are there which act as a matrix, and they can be formed that mix with our sample. So generally the solution of one of these molecule is made, oftenly they are mixed with distilled water or organic solvent like acetonitrile or ethanol or methanol, they can commonly used. Then counter source is trifluoroacetic acid is added to generate M plus H ion. So generally we take that quantity, that is the good example of matrix solution would be 20 milligram ml of cinnamic acid, that is sorry, synapinic acid, that is the 3,5-dimethoxy 4-hydroxycinnamic acid in acetonitrile water and trifluoroacetic acid in the ratio 50s to 50s to 0.1. So very minute quantity of the trifluoroacetic acid is added, just additive, so that can generate M plus H ion. Okay, so how the solution can be prepared with sample and matrix in the proportion is given to us. Now we'll see the how the matrix can be performed. So there are two kind of functions are there. First, it absorbs photon energy from the UV rays, that is the laser beam, and transfer it into the excited energy. So in UV spectroscopy, we have observed that when the UV rays are absorbed by the did undergo excitation, then it serves as solvent for the analyte, so that the intermolecular forces are reduced and aggregation of the analyte molecule is held minimum. So in this case, here when it undergo excitation, it acts as a solvent for the analyte. So the intermolecular forces is reduced and analyte molecule that can be go to the conversion into the ions. So some desirable characteristics of typical MALDI matrices are nothing but the matrices that are nothing but the organic compounds. They are a strong light absorption property at the wavelength of laser flex. The ability to form a microcrystal with the sample always. Otherwise, it is very difficult to act as a matrix. A low sublimation temperature, which facilitate the formation of instantaneous high pressure plumb of matrix sample material during the laser pulse duration. So here always the organic compound having low sublimation temperature. The participation in some kind of photochemical reaction, so that sample molecule can be get ionized very easily, and that gives a very high yield. So these are some characteristic properties of desirable or ideal matrix that are commonly used, and all these three having satisfy all these characteristics, and that's why they can be commonly used. So these are some list of organic compounds which act as a MALDI matrix, that is 2,4-dihydroxybenzoic acid, DHB, that is genestic acid. Solvent used for this is acetonitrile water, methanol, acetochloroform, and on that regard they can know the wavelength of such compound, and it is applicable for nucleotides, peptides, oligosaccharides, oligonucleotides. When such kind of compounds are there, always we can prepare DHB. Similarly, 3,5-dimethoxy 4-hydroxycinnamic acid, that is nothing but synaptic acid, is dissolved in acetonitrile water, acetone or chloroform, and mostly it is applicable for peptide proteins lipid. Then alpha cyano 4-hydroxycinnamic acid, it is also applicable for peptide lipids and nucleotides. And there are picolinic acid and 3-hydroxypicolinic acid, such kind of compounds are there, and they act for the oligonucleotides. So these are some commonly used MALDI matrix are there. Now you can see the laser. So which kind of laser is used? In MALDI technique, we use UV laser, such as nitrogen laser, which having the wavelength 337 nanometer and frequency tripled and quadrupled as 355 nanometer and 266 nanometer respectively. Here, not only UV laser, but in some cases, IR lasers are also used uh, due to their softer mode of ionization. So that is called IR MALDI, and here we can call it as UV MALDI. So it also IR MALDI has advantages of greater material removal, less low mass interference, and compatibility with the other matrix, that is free laser desorption, mass spectrometric methods. So IR MALDI is also having advantages. So on the basis of the requirement of the sample, UV MALDI as well as IR MALDI can be used. Now, as we'll see the mechanism of MALDI, generally the process of the ionization is takes place in a three step, that is the formation of solid solution, matrix excitation, and analyte the ionization. Again, the beats or short question is asked on this, the mechanism of MALDI. So here the formation of solid solution, it is essential for the matrix to be assessed, thus leading to the analyte molecule being completely isolated from each other. So this eases the formation of homogeneous solid solution, and that required to produce a stable desorption of analyte. So formation of solid solution is very important because organic compound and that is matrix and sample, we have to prepare the solution by using a solvent, and we have to coat it on that plate, sample plate, and we have to dry it. So for that purpose, we have to prepare its solution. While in the matrix excitation, the laser beam is focused on the surface of matrix analyte that is already in the crystal form because of the dry. Uh, the chromophore of the matrix coupled with laser frequency causing rapid vibrational excitation and bring about localized disintegration of the solid solution. So it can absorb the photon energy and go to excited state, and there is vibrational excitation is takes place. So this cluster ejection from the surface consists of analyte molecules surrounded by the matrix and salt ions. So this analyte sample is surrounded by the matrix as well as salt ion because of this excitation. And these molecules evaporate away from the cluster to leave the free analyte in the gas phase. So when we can uh, further pass to the ion chamber, these matrix molecules evaporate away from, that is the cluster which is surrounded to the sample or analyte, and only the analyte is free in the form of its ion, and that is in the gas phase. So analyte ionization, that is the third step, in which the photoexcitation matrix molecule are stabilized through the proton transfer to the analyte. So either proton transfer or electron remove, such kind of ion generation process has been carried out over here. So cation attached to the analyte is also encouraged during this process, and it is in this way that characteristics M plus H or M plus X, that is X may be M plus H, M plus Na analyte ions are formed. So that depend upon the whether it can form salt ion or whether it can form a transfer of proton, that depend upon, and that can give M plus H and M plus Na peak. So this ionization reaction takes place in the dissolved matrix analyte cloud just above the surface. And here we have observed that the ions are then excited into the mass spectrometry for analysis. So in the analyzer, further the ions can be accelerated. So these are the three common steps. First, we have to prepare the solid solution based on the sample plate, and then it is dry to get crystallized, and then we have to pass a laser beam on it. So excitation of the vibrational acceleration takes place for matrix, and then they can coupled with, or they can form a cluster around the surface of the analyte molecule. And then it move, or it when it further go to the ion chamber, the evaporation of the matrix molecule is takes place and only left the free analyte. And then it free analyte, when it can be give proton transfer or salt ion transfer, and we can get a characteristic of M plus H and M plus Na ions which are formed. And these ions then dissolve matrix analyte cloud, and then can move to the um, analyzer through slits for where acceleration. So these are the three common steps which are carried out in the matrix. So you must imagine these things how they can be work, and once you know this by imagination, then it is very easy to write down the steps that are involved. No doubt I have given in detail, but if either you should know the two or three lines of each step, then that is also sufficient. That so in writing form, you have to write down the specific steps that are, or you have to give trace on only that points that are very important for the process. Okay, so did you understand these three steps? Any doubt is here? ह्यामध्ये कोणाला काही शंका आहे का? बेसिक प्रिन्सिपल समजलं का?
Yes, sir.
अरे येस और नो?
हो सर. हो सर.
हा, ह्या तिन्ही स्टेप्स शॉर्ट क्वेश्चन साठी, हा शॉर्ट क्वेश्चन साठी, किंवा आपल्याला माहित नाही साधारणतः ऑक्टोबर नंतर, म्हणजे 30 सप्टेंबर पर्यंत जरी कॉलेज नसलं तरी ऑक्टोबर मध्ये जर सुरू झालं, तर तुमची रेग्युलर सारखी जर एक्झाम घेण्याची वेळ आली पुढं ह्या सेमिस्टर मध्ये, तर ह्याच्यावर तुम्हाला बीट्सला क्वेश्चन विचारले जातात. शॉर्ट क्वेश्चन सुद्धा ह्याच्यावर येतो, कारण मालडी आणि ESI हे खूप महत्वाचे आहेत. म्हणजे आता हे ऑलरेडी त्या ह्याच्यामध्ये आहेत. ऑलरेडी आपण वापरतो ह्या दोन्ही टेक्निक. Then we will see the MALDI ionization mechanism. So this is the sample plate, and we have to prepare the solution of analyte and matrix, and after heat drying, it can form a crystalline form. So you can observe a blue color, such kind of matrix are there, green color analytes are there, and they can form a crystalline form. And here these are the cations. So when the laser beam of UV is passed over here, then excitation is takes place, that is vibrational excitation, and they can be form a cluster around this analyte, and then they can be escape through here, and through slits when it can goes. So there is extraction grid is there, so only positively charged ions in the form of M plus H, M plus X, or M plus Na, they can be passed through this, and they through the slits, that is the focusing lens, they can be accelerated and they can move towards the analyzer. So in this way the mechanism is takes place. And for sake of understanding, if you can draw this diagram like this, or in other way, you also write down in a simple way, that is sample and matrix crystallize on the stage, then this is dissolved sample ions and neutrals, there is a UV ray, that is the laser beam, and this is the analyzer through which they can be passed. This is the extraction grid is there, and through which the sample or analyte ions molecule are passed through this. So this is the mechanism. Then how they can be, just we can see the flow chart for this. So laser pulse product produces matrix neutrals, positive as well as negative ions. So this gives molecular ion, then M plus H, M minus H of matrix, they can form initially because of the laser bombarding, and then the sample molecule are ionized by this gas phase proton transfer, that is nothing but this analyzer. So here at initial stage, when the laser beam is bombarded over here, this blue color matrices undergo vibrant excitation, and they can produce molecular ion of that matrix M plus H, M minus H, and then this M plus H or M minus H react with analyte, and that sample molecule or analyte undergo ionization by this phase transfer. So it can form M plus H, M minus H. If there is salt formation is there, so it can form A plus Na. So such kind of ionization is takes place. Now how it can be work? So first of all, you have to take the sample. They can mix with excess of matrix. Then on target plate, we have to coat this, dry it, so it can form co-crystallize. Then we can pass UV rays. Desorption is takes place. That is the pulses of laser light and rapid excitation of the matrix molecules takes place over here. And this rapid heating of the region matrix and analyte ions undergo ejection, and they can be converted into gaseous phase. And because of this gaseous phase, they result in the exploration of sample region into the high vacuum. They can be transferred, and during this procedure, the proton molecules they can be converted in terms of ions, and then later on they are entered to the TOF, that is the analyzer. They can be moved further through this slits are there. Because of that, they can undergo accelerated, so that move towards the TOF, and that's why it is called MALDI TOF. Okay, so this is the working procedure. If you know this, then experimental part is very easy to remember. So did you understand this working process? Any doubt is there? समजले का वर्किंग प्रोसेस?
Yes, sir.
म्हणजे डायग्राम आणि त्याच्यानंतर जर तुम्ही हे दाखवलं तर मला वाटतं कोणालाही त्या ठिकाणी अडचण येण्याची काही कारण नाही. आणि असं थोडंसं एक शॉर्ट मध्ये प्रत्येक प्रोसिजरचं तुम्ही जर असं लिहिलं तर मला वाटतं तुम्हाला समजायला खूप सोपं जाईल. सो यू शुड प्रिपेअर सच काइंड ऑफ फ्लो चार्ट that is very easy to remember along with diagram. So systematically you should remember all ion sources and analyzer. Now we will see the advantages. So it is a gentle ionization technique. High molecular weight analyte can be ionized. Molecule need not be volatile. Wide array of matrices can be used over here, and that can produce singly charged ion. Thus, interpretation become very easy. So mostly we can get one or two signals. So that is very easy to remember. That is M plus H and M plus Na peak, and that are for very easy to find out the molecular weight. Prior separation by chromatography is not required. So that is nothing but by using MALDI. If your sample is pure by TLC, then it is not necessary to use chromatography because we have focused only on the molecular weight of the sample. So used to identify the different strains of viruses to help develop vaccines. So in biochemistry, it is also applicable in the proteins. They are also very applicable. So these are the advantages of the matrix and sources. No doubt there are some disadvantages are also there, or some limitations are also there. So that is nothing but this MALDI matrix cluster ion is very low M by Z. So it requires some very low molecular weight compounds. Analyzed or analyte or sample must have very low vapor pressure. Then pulse nature of source limits compatibility within many mass analyzer, and coupling MALDI with chromatography can be very difficult. And that's why MALDI for the inlet system generally liquid chromatography or chromatography is not be used. So directly we have to take the sample and prepare its solution with matrix. So there is no need of, or it is very difficult to use chromatography as the inlet system. So the analyte that absorbs the laser can be problematic, definitely, because it undergo excitation. If there is any kind of conjugation, then UV absorption is takes place. So we know that when you can find out the lambda max value. So here, if such kind of system is there, that is inon and diene system is there, then obviously they can be absorbed and undergo excitation, and there is mismatch of the molecular weight is also takes place. So that is the limitation of the MALDI. Now we can see the application of MALDI. First is proteomics. So to identify, verify, and quantitate the metabolites, recommend proteins, protein isolated from natural sources, peptides, amino acid sequences, such kind of variety of biomolecules or macromolecules they can be identified. they can be identify, verify by quantitatively by using MALDI as ion source. Then also in the pharmaceutical analysis, this can be widely used for the bioavailability of studies, drug metabolism studies, pharmacokinetics, characterization of potential drugs, drugs degradation product analysis, screening of drugs, and identification of drug targets. Also in microbiology, the MALDI as a source is commonly used for identification of microorganism. Then species diagnosis by the this procedure is much faster, more accurate, and cheaper than other procedure based on biochemical tests, and that's why it is widely used in the microbiology, that is in pharmaceutical industries, and in peptide synthesis. So that is DNA, RNA. Even though it is applicable in the forensic science as a forensic analysis and environmental analysis, is application of the MALDI, that is the pesticides on food, that is easily analyzed, and soil and groundwater contamination is also find out by using this MALDI, and that's why it having a very wide application in all sector of the surrounding. Now we can see the next part of this in continuation with ionization. That is nothing but in atmospheric pressure ionization, the analyte molecule is ionized first at atmospheric pressure. So by using the atmospheric pressure, we have to form the analyte molecule is converted to the analyte ions, that can be mechanically and electrostatically separated from neutral molecules. That process is carried out in presence of atmospheric pressure, and there are two types of such kind of ionization techniques are there. First is atmospheric pressure chemical ionization, that is APCI, and atmospheric pressure photoionization, that is APPI. So these two techniques are now we will see one by one. So in that case, we can start with atmospheric pressure chemical ionization. So that is nothing but we use chemical ionization already we have seen in detail, and along with that only we have to give the atmospheric pressure. So by using atmospheric pressure, initially the analyte molecule undergo ionization, and then mechanically and electrostatically we have observed that electric field and magnetic field is applied in the accelerator. So once we can bombarding the electrons, or after that when it go to the uh, through slit, it undergo accelerate, and then on the basis of mass to charge ratio, that is it go to the analyzer, that is nothing but there is a magnetic and electric field, both are there. So electromagnetic fields are there on either side, and they can be uh, mm, passed through that on the basis of their mass to charge ratio to the detector. So that is the basic principle. Be remember, in all these cases you must know the basic components as well as their function. Once you know in detail, then it is very easy to find out the which technique is used. That is the part you have to just think over it. Now we'll see one by one, that is atmospheric pressure chemical ionization. So in atmospheric pressure chemical ionization, it is the ionization method used in mass spectroscopy mostly. LCMS, that is nothing but liquid chromatography, is act as a here inlet system which utilizes the gas phase and molecules reaction at atmospheric pressure. It is an ionization method that is similar to the chemical ionization, because name itself will indicate it is atmospheric pressure chemical ionization. So here it is used in GCMS, where corona discharge electrode is used on a solvent spray produce primary ions. APCI is mainly used with polar, relatively non-polar compounds are also there. They can be used with a molecular weight less than 1500 Dalton, generally giving a monocharged ions are there. So that is nothing but in this case, it procedure of the ionization is similar to the chemical ionization, and that is commonly used in GCMS and LCMS. Mostly we can use the coronary discharge electrode on a solvents produce primary ions. So this is the now we will see the principle. So that is the introductory part of APCI. So in APCI, the sample is typically dissolved in solvent and pumped through the capillary inside the uncharged couch tube. So that is nothing but from the inlet system. Generally, we can use column, that is liquid chromatography. So in terms of HPLC liquid chromatography, we can use column to pass this sample. So at the end of capillary, but still within the tube, sample is covered with to the aerosol or then vaporized with the help of nitrogen gas. So what is the role of nitrogen gas? Which act as a nebulizer. And by heating to a very high temperature, around about 350 to 550 degrees Celsius, so the gas solvent and sample are then ionized by coronary discharge electrode is there. So this is the coronary discharge electrode in which a highly charged electrode create an electric field which is strong enough to ionize the nearby molecules. So when gas solvent as well as the sample molecules are nearby this coronary discharge electrode, so that can create electric field, and because of that only the sample undergo ionization. A potential several kilovolt applied to the electrode typically remove an electron from the neutral molecules without depositing enough internal energy to cause fragmentation. So this very important thing is that, so when we apply to the electrode, so this potential is applied to the electrode, typically remove an electron from the neutral molecule without depositing any internal energy to cause fragmentation. So without fragmentation, only electron can be removed, and this coronary discharge electrode may directly ionize the analyte molecule to form a radical cation, that is molecular ion is formed. Okay, so what is this electron is removed, so it can form molecular ion. And here this solvent also get the such kind of thing. So frequent collision between the ions and molecule can be transferred from ion to the another neutral. So collision of the ionized solvent ion, so this is S for solvent, M for molecule. So here that we already seen, the solvent also get ion peak, molecular ion peak. So collision of the ionized solvent ion with analyte molecule can also take place. So that is nothing but if there is a solvent molecular ion peak, it react with neutral sample molecule, and then there is transfer of the charges takes place, and we can get the molecular ion peak. So collision of this ionized solvent ion with analyte molecule can create a direct charge transfer to form a radical cation anion. So that is nothing but either by using the coronary discharge electrode, they can directly ionize the sample, analyte sample, to the radical cation. Also the solvent also undergo formation of radical cation, and which collides with the neutral molecule or analyte molecule to form the analyte radical cation. So by using either this method, the molecular ion can be formed. Okay, did you understand the principle? प्रिन्सिपल
Yes,
समजले
sir.
का? येस ऑर नो? हा हा, म्हणजे यामध्ये आपल्याला काय करायचं आहे, सोल्युशन बनवायचं आहे. ठीक आहे, ते लिक्विड क्रोमॅटोग्राफी मधनं पास करायचं आहे. ज्या सिस्टीम मध्ये त्याला प्रेशर दिलेला आहे, त्या ठिकाणी आपण सॅम्पल कॅपिलरीच्या थ्रू पास करणार आहोत. ते केल्यानंतर कन्वर्टेड टू एअर सोल मध्ये ड्रॉपलेट्सच्या फॉर्म मध्ये दे कॅन बी व्हेपराइज्ड विथ हेल्प ऑफ नायट्रोजन गॅस विच ऍक्ट एज अ नोबलाइज विच इज सराउंडेड दिस कॅपिलरी, and heating is takes place at high temperature. Under vacuum we can carry out such procedure, and that's why it is called atmospheric pressure is there. And in that case, this electrode is there, and these droplets when they are coming nearby this electrode, that can create ions. Directly the electron can be absorbed from the molecule or solvent, they can form molecular ion, radical cation for molecular as well as solvent, and there is collision is takes place. So such kind of principle is there for this APCI technique. Now alternatively, collision of the solvent ion with the neutral analyte molecule may result in the absorption or abstraction of the hydrogen atom to form the molecule. The resulting ionized solvent can be ionized the analyte via proton transfer. So that is nothing but in this case, whatever the solvent molecular ion is there, it also react with solvent itself, and it can form S plus H ion, and this H plus H solvent ion react with the neutral molecule, and there is transfer of proton is takes place, and here we can get M plus H peak and solvent. So the resulting analyte ion, that is M plus, that is molecular ion and M plus H peak, are then injected into the mass spectrometer for detection. So they can further identify the molecular ion. So this is the very important thing. 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 So this is the accelerated through slit and transferred to the analyzer. So generally acetonitrile and water system is there. And 0.5 ml per minute is supplied to APCI probe by the pump, that is either from HPLC or liquid chromatography, that is in the inlet system. So we have to prepare the solution, and that can be 0.5 per ml by the pump. Then liquid spray is produced by passing coaxial nebulizer gases there, that is nitrogen is surrounded to this capillary. Then solvent spray is vaporized by heating, and once formed vapor is emanating from corona electrode, that is corona pin held at 3 kilovolt. The electric field is sufficiently strong to ionize the solvent vapor either by removal of positive ion, that is removal or donation of the electron is there. Either we can that solvent is absorbed or that can be donated. So on that basis they can form positive ion as well as negative ions. Then ion or molecule react, that is the reaction is takes place, and the result in the formation of reactive species in terms of ion M plus H and molecular ion can be formed. And here, for example, when we can take methanol is used, just we have to elaborate this methanol acetonitrile. So what will happen in this case? The methanol can form molecular ion, and it can react with neutral solvent, again methanol, so it can form MEOH twice plus. Now this can form a M plus S plus H, right? So whatever we have written there, S plus H, that is nothing but in this way the reaction is carried out. Similarly, when it can methanol can absorb the electron, it can form M minus, that is S minus, and this solvent methanol, when it can form MEO minus and H2. So either in the positive as well as negative of the solvent is takes place by using this positive as well as negative ion of the APCI technique. Then acid base reaction takes place between the sample and reagent gas, resulting in the protonation, that is the positive ion mode, and negative ion mode, that is deprotonation of the sample as well as solvent molecule. And here once they can form this M plus H, they react with molecule to form M plus H molecule, that is M plus H ion and methanol. Similarly, the negative ion, that is proton from this molecular ion, a molecule, neutral molecule is take by this negative ion, so it can form methanol and M minus H peak. So that is nothing but by using APCI we can observe M plus H peak of the analyte and M minus H peak of the analyte. And they can be transferred to the mass analyzer by the small voltage through this is there, so that is in the word slit, and the pressure difference between the source and analyzer region is maintained by the presence of the area of intermediate vacuum. So during this ionization process itself, the little energy is transferred to the sample molecule and fragmentation is very less. So upon acceleration of the sample ion through the hot solvent vapor, collisional activation is takes place, and subsequently the fragmentation is commonly carried out. So this is the working procedure of the APCI. This is the liquid chromatography. Just we are focused over here. There is heated nebulizer, nitrogen is surrounded. This is capillary liquid in the form of droplets. The solvent molecules are there along with solute, and this is the corona needle electrode is there. So this is the formation of aerosol. Then vaporization of the solvent and sample is takes place over here in this vacuum system. And this corona needle, that is electrode, they can be formed in terms of solute ions are formed, that is M plus H, and charge transfer and collision is takes place, and they can pass further. So it is better to draw such kind of diagram, that is liquid chromatography, nebulizer gas, nitrogen, and through this capillary along with the solution is there. So it can be heated over here, so they can be converted in terms of aerosol, that is a spray temperature sensor is there 120 degrees Celsius, they can form. This is the corona discharge electrode is there, and when they are in contact with this, they can be converted in terms of solute ions for solvent as well as molecule, and then the collision is takes place, and they can form charge transfer, and molecular ion are observed with respect to their mass to charge ratio, and they can be passed through this slit to the analyzer. So this is the skimmer, and they can pass further to the analyzer. So this is the working procedure of the APCI. So this can be applied for organic compounds with medium high polarity. Since positive ionization is depends upon protonation, basic functional compounds such as amino acids, amides, esters, aldehydes, ketones, hydroxides can be easily analyzed. Also, there is negative ionization is takes place that depends upon the deprotonation of molecule. So mostly acidic functional group compounds are also analyzed by this method, and it can be used as LCMS interface. So in the analysis of pesticides and uh, analysis of triazides, phenolurias, carbamates, organophosphorus compounds. So mostly they are related to the carbohydrates, sugars, nucleosides, nucleotides. So such kind of samples can be analyzed by using this APCI. So the in the determination of vitamin D3, this can be used. Now you can see the advantages. So multiple charge is typically not observed as ionization because only M plus and H and M minus H is there. So electron transfer or proton loss occur in the negative mode while proton transfer in positive mode is takes place. So atmospheric pressure, analyte molecule collides with reagent ion frequently and hence ionization is sufficient. Also it is effective. Some disadvantages are also there. So very sensitive to contaminants such alkali metals or basic compounds. Uh, Very low ion current is there through electrode. The relatively complex hardware compared to other ion sources are there, and that's are some limitation of this APCI. So in this way, the APCI is completed. So MALDI and APCI. So generally MALDI is commonly asked, and it is applicable in various mass spectrometry instrumentation. So did you understand? ह्यामध्ये काही शंका आहे कोणाला?
No, sir.
ओके. मला वाटतंय अजून काही कोणी मुलं त्या ठिकाणी वाढलेली दिसत नाहीत. परत मेसेज पाठवलाय का
हो
अफसाना?
सर, केलाय ग्रुपवर मेसेज. हो सर, ग्रुपवर केलाय
ते सुद्धा
मेसेज.
14च आहेत. मग याचा अर्थ मुलांना अजूनही त्याचं गांभीर्य लक्षात आलेलं दिसत नाहीये. जरी तुम्ही लेक्चरला नसला तरी त्या वेळेसच्या ह्याला कोण असाल ते आता आमच्याकडे त्याची प्रेझेंटी तेव्हा नसणार आहे. तुम्ही तुमची एक्झाम द्यायची आणि हे करायचंय. त्यामुळे जर कोणाला काही शंका असेल तर मला वाटतंय विचारायला हरकत नाही. अनुपमा नायर, इफ यू हॅव एनी डाऊट regarding
No, sir.
exam as well as so are you ready for exam?
Yes, sir.
हॅलो
So
सर.
ha, yes,
सर
बोल
कॉलेज
पाटील.
ऑक्टोबर मध्ये स्टार्ट होतील का सर? कॉलेज सर ऑक्टोबर मध्ये स्टार्ट होतील?
आता कॉलेज ऑक्टोबरमध्ये स्टार्ट होतील हे आत्ताच सांगणं थोडंसं कठीण आहे, कारण ह्यांनी सप्टेंबर एंड पर्यंत कॉलेजेस बंद ठेवायला सांगितलेत. परंतु हे होत असताना एक वस्तुस्थिती तुम्ही लक्षात घ्या. द रिअलिस्टिक पॉइंट यू मस्ट रिमेंबर दॅट as the number of corona patients goes on increasing day by day in Satara also. Like at initial stage, in the beginning of August, there is 200, 300, and now we are crossing 600 daily. So in such kind of situation in the rural areas, not only in urban, and hope so September, and then that goes on decreasing because if you observed in whole over India, the number of corona patient is almost 75 to 80,000. So we are just maybe probably within 2 to 3 days we will cross the Brazil also. So that scenario is totally different because central ministry has told yesterday, and as per their guideline, probably they have mentioned that in the third week, if you have any kind of doubt for 9 to 10 12 student regarding their syllabus, and they should take the prior permission of their parents in return and come to the school. So likewise also, maybe in the third week, if college have given such kind of information, then you should come or discuss with this. But we hope that probably in October we can start and physically we will there. So it is a very helpful situation. But this is the only college that we have already taken initiative at very early stage. And I think in COVID-19 also we have start our regular teaching in July, that we have already started. started regularly uh, in our routine work also, and so that is not much affect to you people. Only rest of the thing is that those who have not all clear the subject, so you must focus on that simultaneously. If there will be exam for last year final year student, there is also possibility that there should be an exam on that basis similar to you also, because you may be ready at any stage, those who have having back the subject. Okay, अजून काय शंका आहे?
No, sir.
हा ठीक आहे, आज थांबूया कारण आपल्याला परत तुम्हाला टेस्ट आहे, त्यामुळे एक्झॅक्ट टायमिंगला लेक्चर हे होणं गरजेचं आहे. आता मला वाटतं बहुतेक मॅडम पण जॉईन झालेले दिसत आहेत, आणि मी या ठिकाणी लगेच लेफ्ट होतो. आणि ह्याचं जे काय असेल ते आपण नंतर मटेरियल हे करू. आणि बेस्ट ऑफ लक, तुमची पहिलीच एक्झाम होतीये ह्या ऑनलाईन मोडमध्ये. जर काही हे असतील तर तुम्ही नंतर व्हॉट्सअपवर हे करा, आणि मला इन्फॉर्मेशन आली की मी लगेच तुम्हाला व्हॉट्सअप ग्रुपला शेअर करेल. साधारणतः 11च्या आसपास त्यांनी लिंक दिल्या, तर लिंक जरी दिलेली असली अगोदर, तरी लिंकला तुम्ही अगोदर क्लिक करू नका. ज्या टायमिंगला दिलंय त्या टायमिंगलाच ती ऍक्टिव्हेट होणार आहे, आणि त्या 10 मिनिटांमध्येच ती हे राहणार आहे. त्यामुळं 11 वाजून 15 मिनिटांनी एक्झॅक्टली, वाटल्यास 11:16 करा, पण 15ला पण क्लिक करू नका, एखादा मिनिटं जाऊ देत. कारण 10च एमसीक्यू आहेत, आणि 10 एमसीक्यू सोडवायला मला वाटते 5 ते 7 मिनिटं मोर दॅन सफिशियंट असतात. त्यामुळं एखाद दुसऱ्या मिनिटात गेल्यानंतर तुम्ही ती चालू करा. आणि प्रत्येकाला सेपरेट लिंक येणार आहे, त्यामुळे ऑर्गॅनिक वाल्यांची वेगळी, इनऑर्गॅनिक वाल्यांची वेगळी, अनालिटिकल वाल्यांची वेगळी असणार आहे. आणि त्या ठिकाणी तुम्हाला तेवढ्या ह्याच्यामध्ये आन्सर देऊन ती सबमिट करायची आहे. आणि इकडे तिकडे हे न करता तुम्ही तुमचे आन्सर हे करून शेवटी सबमिट झाले की नाही ते कन्फर्म करा. नाही तर टाइम संपत असताना बरेच वेळा काय होतं, तुम्ही सबमिटच करत नाही आणि आन्सर हे झाले, अशा केसमध्ये मग तुम्हाला मार्क कमी पडले, काय झालं, अशा शंका येऊ शकतात. त्यामुळे ह्या ठिकाणी 1 मिनिट कमी असताना, साधारणतः समजा 1 मिनिट उशिरा सुरू झालं तुमच्याकडनं, तर 9 मिनिटाचा तुम्ही टाइम स्पॅन ठेवा की ज्याच्यामध्ये आपल्याला आपले 10 क्वेश्चन सोडवायचे. आणि 9व्या मिनिटाला म्हणजे घड्याळ तुमच्याकडे असणं गरजेचं आहे, आणि ते 9व्या मिनिटाला तुम्ही ती सबमिट करायची. ठीक आहे, ओके, बेस्ट ऑफ लक.
थँक्यू सर.
Thank you, sir.
हा, मॅडम आलेल्या आहेत, आता मॅडम सुरू करतील.
Okay. Good morning.
Morning,
गुड
ma'am.
मॉर्निंग मॅम.
Good
गुड मॉर्निंग मॅम.
ma'am.
So everybody is tensed for exam. Ready or tensed?
रेडी मॅम.
Ready. Very
Ready.
good. Very good. See, this is a practice test or surprise test. 10 MCQ for 10 marks. And when it is a surprise test, remember it is always a conceptual or say basic understanding of that topic. You have learned till 6 lectures for this acid, 6 or 7 lectures for acid base equilibrium, and the questions are set based on those PPT only. So what you have to do is just go through the presentations of all the papers, not only for me, of all the papers, and solve the questions. It will be a very interesting test for you. Okay. So let us start immediately so that I'll be finishing 10 minutes earlier so that you can be ready to solve the questions. Okay. Best of luck. So let us start with today's lecture. Today it is very simple lecture. No mathematics, no problems, and only application part of buffer. Till now what we have studied is what are buffers, what are types of buffers, how to prepare a buffer, how to calculate pH of buffer, the Henderson-Hasselbalch equation. So the chemistry of buffer is ready. Now what are the applications of buffers, what are physiological buffers, and how they are useful in clinical and biological measurements. See, what are the applications of buffers? The first application is in biological systems, where the pH of blood, you know that it is 7.4 and it is maintained by buffers which are present in body. So there are two types, there are two buffers present. First is primary buffer, these are present in plasma. plasma contains carbonic acid and carbonate. This is known as carbonate buffer. And the second buffer is acid or alkali, which is phosphoric acid or and sodium salt of phosphoric acid. So this is known as phosphate buffer. These two buffers, which are present in blood plasma, or these are present in intracellular and extracellular part, are responsible to maintain pH of buffer. And this is physiology. This we'll study in detail in the latter part of this lecture. Second application is in pharmaceutical system. Pharmaceutical, you all know that it is the drug industry or medicine industry. Buffers are widely used in field of pharmacy as ingredients in most of the pharmaceutical formulations in order to adjust the pH of product to their required for to that required for maximum stability. Few students were working with me on the MSc project, and for them I have given the assignment or the problem regarding stability of pharmaceutical drugs. If you remember, आठवतंय का कोण कोण होतं? ड्रग स्टॅबिलिटीचा प्रॉब्लेम मी तुम्हाला दिलेला आहे. And what is the effect of light? What is the effect of storage on the stability of drug? त्याच्या की लाईटचा मी पर्टिक्युलरली प्रोजेक्ट त्यांना दिलेला होता. ओके, सो what is important in pharmaceutical industry is to maintain the pH of that drug so as to retain its stability for maximum period, so as to keep it stable for long period. And for this reason, for every on every drug, it is written as date of manufacturing and date of expiry. The reason is this: in parenteral preparations, in simple words, in injections, in case of injections, pH should be considered carefully as large deviations of pH may lead to serious consequences. You know that injections are directly injected in the body, as a result of which the solution is directly introduced into your cells. And for this reason, proper pH of that solution which is to be injected is very essential. And for this reason, stability is important, and the stability is maintained by buffers. Then third part is the ideal pH of this injection product is 7.4, which is very similar to the pH of blood. And the reason is same. If you inject a different pH solution, it will compete with blood, and there will be exchange of H plus ions from that solution to blood or from blood to solution. For this reason, the pH of these injectable solutions is to be maintained at 7.4. Then the most commonly used buffer in injections are acetate buffer, phosphate buffer, citrate buffer, and glutamate buffer. Glutamate is somewhat different for you, but will not go into details. You know, you can easily understand what is acetate buffer, what is phosphate buffer, what is citrate buffer, citric acid and its salt with sodium, and glutamate is glutamic acid. Well, actually this is related to amino acid, and it is directly related to buffers which are present in proteins or amino acids, and that is glutamate buffer. Then the third application is in ophthalmic preparation. What is ophthalmology? Do you know? Yes? Hello?
Yes, ma'am.
What is ophthalmology? Can anybody understand?
Eyes.
Eyes. Okay. चष्म्याचा नंबर काढणे, डोळे कोरडे पडले, डोळ्यात औषध घालणे. ओके. अजून काचबिंदू झाला, मोतीबिंदू झाला, माहिती की नाही सगळ्यांना? There are many problems related to eye, and these problems related to eye are properly maintained by some buffers. Buffers are generally used in ophthalmic preparation to maintain the pH within the physiological pH range of lacrimal fluid. What is lacrimal fluid? The fluid which is present in your eye. पाणीदार डोळे आपण म्हणतो. The eye fluid is lacrimal gland is the gland which is responsible for tears actually. and the function of this gland is to maintain proper concentration or proper percentage of eye in the fluid in the eye. And for this reason, a special pH is to be maintained in your eye. And this pH is maintained by buffers which are present in eyes. The lacrimal fluid has pH in the range of 7 to 8, but it has good buffering capacity and can tolerate preparations having pH values between 3.5 to 10.5 with with little discomfort. Outside this range, that is 3.5 to 10.5, increase, increase lacrimation may occur with complications. आता लक्षात घ्या, कांदा कापायला लागला की आपल्या डोळ्यातनं पाणी येतं. Why? What is the reason? What is the reason for burning of eyes?
कांद्यात काहीतरी केमिकल
काय काहीतरी नाही, काय केमिकल असतं जे डोळ्यात
फॉर्म
हम्म?
ऍसिडिक फॉर्म.
ऍसिडिक फॉर्म. ओके, तर हा जो पार्ट आहे, दिस इज व्हेरी इम्पॉर्टंट. तुमच्या डोळ्यामध्ये जे काय जातं त्याची रिॲक्शन होते. पीएच जर प्रॉपर नाही मेंटेन झाला तर तो मेंटेन करण्यासाठी ही जी लॅक्रिमल ग्लँड असते ती काय करते, ती फ्लुइड रिलीज करते आणि ते रिलीज केलेल्या फ्लुइड बरोबर ते डोळ्यातनं निघून जातं, ज्याला आपण डोळ्यातनं पाणी येणे म्हणतो किंवा अश्रू येणे म्हणतो. ओके, सो दिस इज मेंटेन बाय बफर्स इन आईज. किती? व्हॉट इज द पीएच? 7 to 8. You can easily see all the body fluid pH is maintained between the range of 7 to 8. 7.4 is blood, त्याच्या आसपास या सगळ्यांचा पीएच आहे. ओके, दिस रेंज इज व्हेरी लार्ज, 3.5 to 10.5, म्हणजे काही चेंजेस सस्टेन करू शकतो, बट बियॉन्ड दॅट द पीएच इज मेंटेन बाय दिस फ्लुइड. द बफरिंग एजंट्स most commonly used in ophthalmic preparation include borate buffer, carbonate or phosphate buffer. Okay, borate buffer is boric acid, that is known as hydroboric acid, and its salt sodium borate. याचं मिळून म्हणजे आता तुम्ही विचार करा की बफर आपण नुसतं सोल्युशन्स आपण वी यूज सोल्युशन्स इन लॅबोरेटरी इन बिकर्स और टेस्ट ट्यूब्स. ओके, बट इफ यू इमॅजिन युअर बॉडी हॅज सो मेनी बफर्स, your body has so many pH complications. So this is the purpose of this topic. The purpose of this acid base equilibrium is because of this, because being analytical chemist you must know the relation between chemistry pH and body pH, and this is the reason for inclusion of this topic in your syllabus. Okay, so this is about ophthalmic fluid, or that is eye preparations. Then the next part is in ointments and creams. Ointments म्हणजे काय? We use different creams, we use different oil solutions. वेगवेगळ्या प्रकारचे मलम आपण लावतो. पाठ दुखली मूव लावलं, हात दुखला आयोडेक्स लावलं, बरोबर आहे, किंवा साधं तेल वापरतो, क्रीम वापरतो. तर इन टॉपिकल प्रोडक्ट्स, these are known as topical products which are used on skin. सरफेसला जे वापरले जातात त्याला म्हणतात topical products, such as ointments and creams, are also buffered to ensure stability for the formulation. In order to keep these ointments for a long period of time as it is, okay, so in order to maintain it should be provided with a specific pH, and for this, to attain this stability, okay, of ointment, most commonly used buffers are citric acid and its salt, phosphoric acid and its salt. You know that citric acid which is present in लेमन अल्सो, आणि म्हणून बऱ्याचशा ऑइंटमेंटला किंवा बऱ्याचदा आपल्याला आयुर्वेदिक सल्ला दिला जातो, लिंबू लावा, लिंबू सोळा. द रिझन इज it has a cleansing action as well as it maintains the proper pH of surface, and for this reason the ointments are provided with buffers in order to ensure its stability for a long period. If it is unstable, what happens? बऱ्याचदा क्रीमला पाणी सुटलेलं असतं की नाही? आपण ज्या टूथपेस्ट वापरतो याला पण खूप जुनी झाली असेल तर त्याला पाणी सुटतं, त्याचा बल्क वेगळा होतो आणि पाणी बाहेर येतं वेगवेगळ्या प्रकारे. दिस इज बिकॉज द पीएच हॅज बीन चेंज, आणि मग आपण त्याला म्हणतो की ही खराब झाली आहे, टाकून द्या. सो दिस इज द इम्पॉर्टन्स ऑफ बफर्स इन व्हेरियस आस्पेक्ट्स. ओके, नाऊ let us move to the important part. Why does body have buffer system? मग आता हे बफर्सचे ऍप्लिकेशन्स आपण बघितले. मग बॉडीमध्ये बफर्स का लागतात? What is the reason for buffer system in body? The very first part is buffer whose pK are well. कुठले बफर लागतात याचा आपण आधी विचार करू. What are the essentials of buffer system in body? Or what are the requirement of buffer systems in body? पहिली रिक्वायरमेंट काय? Buffer whose pK are near to normal blood pH. नॉर्मल ब्लडचा pH किती असतो? 7.4. ओके, त्याचा pK किती होणार? The pK will be somewhat between 6 to 7. pKa means minus log of the Ka value, dissociation constant value. And because of that dissociation constant value, you can easily find out its pK. So the buffers having pK near to blood pH are essential. Second point is, in blood, maintain pH between 7.3 to 7.4. Normal pH 7.4 आपण म्हणतो, and in order to maintain that pH we need buffer systems in body. म्हणजे buffer system कशी असली पाहिजे? Which can help to maintain the pH at constant value. A change in pH of blood affects uptake of oxygen and cellular process. मग pH बदलला की काय होतं? Change in pH of blood affects the uptake of oxygen and cellular processes. म्हणजे जो तुम्ही श्वास घेता त्याचा जर अपटेक चेंज झाला, म्हणजे जेवढा रिक्वायर्ड व्हॉल्यूम आहे तेवढा गेला नाही, त्याच्यापेक्षा व्हॉट आर द पॉसिबिलिटीज? जास्त गेला किंवा कमी गेला. द चेंज इन अपटेक ऑफ ऑक्सिजन, इट चेंजेस द सेल्युलर प्रोसेसेस. ओके, cellular metabolism yields acid. Third point is the metabolism also yields acids. वेगवेगळ्या प्रकारचे ऍसिड फॉर्म होतात बिकॉज ऑफ मेटाबॉलिझम. Then production of basic components which is negligible, such as bicarbonates etc. म्हणजे शरीरामध्ये जे एक्सक्रिटरी प्रोडक्ट्स तयार होतात ज्याच्यामध्ये काही ऍसिड्स असतात आणि काही बेसिक कंपोनेंट्स असतात. मग हे जे ऍसिड आणि बेसिक कंपोनेंट असतात याच्याशी रिॲक्ट करून जो पीएच मेंटेन ठेवू शकेल असा बफर आपल्याला लागतो. सो वी नीड टू हॅव अ स्पेशल टाइप ऑफ बफर इन बॉडी विच कॅन मेंटेन ऍसिड कंटेंट अँड बेस कंटेंट बॅलन्स इन अवर बॉडी. ओके, so important in proper functioning of cells and blood. So finally what is important is the buffer should maintain proper functioning of cells and blood, and for this reason we need a proper buffer system in our body. So buffers for biological and clinical measurements. कुठले कुठले बफर्स लागतात क्लिनिकल मेजरमेंट मध्ये किंवा बायोलॉजिकल मेजरमेंट मध्ये? Many biological reactions occur in the pH range of 6 to 8. What is the pH range? 6 to 8. So this pH range has to be maintained by buffer. Specific enzyme reactions. In addition, there are some enzymatic reactions which occur at a pH range of 4 to 10. 4 ते 10 pH पण आपल्याला लागते. आणि मग या रिएक्शन प्रॉपर व्हायच्या असतील तर इट इज व्हेरी इम्पॉर्टंट to select a proper buffer for the study of biological reactions and for clinical analysis. आणि मग याच्यासाठी सिलेक्शन ऑफ प्रॉपर बफर इज व्हेरी इम्पॉर्टंट. फॉर दिस रिझन सिलेक्शन ऑफ प्रॉपर बफर इज व्हेरी इम्पॉर्टंट. आणि असं बफर पाहिजे ज्याचा पीके व्हॅल्यू सुद्धा कसा असला पाहिजे? करेक्ट असला पाहिजे, प्रॉपर पीके व्हॅल्यू. आणि या सगळ्या गोष्टी जो मेंटेन करू शकेल असा बफर आपण बघणार. द रेशो ऑफ सॉल्ट टू ऍसिड. कुठे शिकलो आपण हा रेशो? सॉल्ट टू ऍसिड. In the Henderson-Hasselbalch equation, we know that if this ratio is 1, pH is equal to pK. So you have to choose a buffer system for which this ratio, salt to acid ratio, must be near to unity. Not exactly unity, but it is somewhat near to unity so that it should be a flexible combination so as to maintain proper pK, then proper pH. And it must be physiologically compatible. फिजिओलॉजिकली कंपॅटेबल म्हणजे तो आपल्या बॉडी फ्लुइड मध्ये प्रॉपर त्याचं फंक्शनिंग झालं पाहिजे. असं नाही झालं पाहिजे की त्याची रिॲक्शन वेगळी आणि तुमच्या बॉडी फ्लुइडची रिॲक्शन वेगळी. So see what I have given the title to this slide. They keep you alive. Because of these systems are present in your body, you are alive. This is so important. There are three important buffer system in our body: protein buffer system, carbonic acid bicarbonate buffer system, and phosphate buffer system. किती आहेत तर तीन बफर सिस्टीम आहेत: प्रोटीन बफर सिस्टीम, कार्बोनेट बफर सिस्टीम and phosphate buffer system. See this chart. In our body, buffer systems occurs in ICF, that is intracellular fluid. What is the meaning of intracellular fluid? I should say cell fluid or cell plasma. And extracellular fluid, cellच्या बाहेरचा जो fluid असतो, body fluid or say blood etc., that is known as extracellular fluid. So this intracellular fluid includes phosphate buffer and protein buffer, whereas extracellular fluid includes carbonate buffer and protein buffer. These protein buffers are again divided into three types: hemoglobin buffer system, which is present in RBC; amino acid buffer system, which is present in proteins; and plasma protein buffers. Okay, so these are the buffer systems which are very important when you study your body physiology or the importance of buffer system in your body. So mainly protein buffer system regulate the pH in both ICF and ECF, extracellular and intracellular. It interact extensively with other buffer systems. वेगवेगळ्या बफर सिस्टीम बरोबर ती इंटरॅक्ट करते. इट रेग्युलेट्स द पीएच ऑफ युअर बॉडी फ्लुइड. Carbonic acid and bicarbonate buffer system is important in extracellular buffers particularly. And why? Because it produces acid that we'll study later. And phosphate buffer system operates in intracellular fluids only, and of course in urine particularly. So this is the summary of buffer system which is present in your body, and this is very important, these three buffers, and we will be studying the physiology of body related to these three buffers. Today we'll study only one buffer system, that is bicarbonate buffer system. Okay, which is important in extracellular. Intracellular आपण नेक्स्ट लेक्चरला बघू, आणि मी तुम्हाला अभ्यास करायला थोडासा वेळ देईल. सो what is bicarbonate buffer system? Remember, bicarbonate buffer system or carbonate buffer system is a combination of bicarbonate, that is sodium bicarbonate, and carbonic acid. That is, carbonic acid is H2CO3 and bicarbonate is SCO3 minus. Okay. Most important and predominant ECF system in our body. It has a pKa value 6.4. 6.4 म्हणजे त्याचा pH किती असणार? Greater than 7. Okay. Carbonic acid is a weak acid and its conjugate base is bicarbonate ion. This is the simple composition of carbonate buffer. Now see what happens. Due to physiological mechanism, your body produces or generates CO2. तुम्हाला माहिती आहे, ऑक्सिजन आत घेतो आणि CO2 बाहेर सोडतो. मग हा जो CO2 बाहेर जातो किंवा हा जो बाहेर सोडलेला असतो, इट इज द बाय प्रोडक्ट ऑफ सेल्युलर रिस्पिरेशन. इट डिझॉल्व्स इन ब्लड. तो शरीरात कुठे जातो? ब्लड मध्ये डिझॉल्व्ह होतो. इट इज टेकन बाय आरबीसी. ब्लड मधले आरबीसी तो घेतात. मग तो जो आरबीसी कडे जातो, इट इज हायड्रेटेड टू कार्बोनिक ऍसिड बाय दिस इज कॅटलिस्ट, एन्झाइम कॅटलिस्ट. तुम्ही गेल्या वर्षी मी तुम्हाला शिकवलंय, हायड्रेज ए झाला की तो काय झाला? एन्झाइम झाला. कार्बोनिक अनहायड्रेज नावाच्या कॅटलिस्टमुळे तो काय होतो? इट इज कन्वर्टेड इनटू कार्बोनिक ऍसिड. त्याची रिॲक्शन मी दाखवते पुढे. दिस कार्बोनिक ऍसिड which is generated dissociates into bicarbonate ions and hydrogen ions, that is HCO3 minus and H plus ion. And this H plus and HCO3 minus ions which are generated, bicarbonate ions are transported to lungs by binding with Hb. मग हे जे जनरेट झालेले असतात bicarbonate ions, this binds with Hb. What is Hb? Hemoglobin, which is present in blood. And this Hb, which is this binding byproduct, is transported to lungs by binding with Hb. म्हणजे हा जो CO2 तयार झालेला आहे, हा आता लंग्स मध्ये आला ब्लडच्या थ्रू, त्याच्यामध्ये एवढ्या रिॲक्शन्स ब्लड मध्ये झाल्या. नाव इट इज ब्लॉट टू लंग्स, आणि लंग्स मध्ये आल्यानंतर इट इज डिहायड्रेटेड टू CO2 अगेन. त्याचं परत कशात कन्व्हर्शन झालं? CO2 मध्ये कन्व्हर्शन झालं. आणि CO2 हा काय झाला तुमच्या शरीरातनं एक्झलेशन म्हणजे तुम्ही जो उच्छ्वास बाहेर करता त्याच्यातनं तो काय झाला बाहेर पडला. दिस इज द सिंपल फिजिओलॉजिकल मेकॅनिझम. म्हणजे आपण श्वास घेताना म्हणतो हवा आत घेतली आणि हवा बाहेर सोडली म्हणजे कार्बन डायऑक्साईड सोडला. इन द मीन वाईल किती वेळात होते? एक श्वास आणि एक उच्छ्वास याच्यामध्ये खूप छोटस अंतर असतं. इट इज अ मॅटर ऑफ फ्रॅक्शन ऑफ सेकंड. And within fraction of seconds, so many changes takes place, and finally CO2 is given out. And this is maintained by this bicarbonate buffer, which is present in your extracellular buffer, extracellular body fluid. Okay, and for this reason, buffer, which is very important. So why carbonate buffer only? Phosphate buffer or protein buffer? Why not phosphate or protein buffer? As I told you, it is the mixture of carbonic acid and bicarbonate. Carbonic acid is H2CO3, which is in equilibrium with bicarbonate, that is HCO3 minus and H plus. It has a pKa value of 6.4. What is it? 6.4. मगाशी मी तुम्हाला सांगितलं. मग आता why this pKa value and why this is 6.4? See here, when a base is added to blood would be neutralized by the following reaction. म्हणजे ही जी बफर सिस्टीम आहे, ब्लड मध्ये जर बेसचं पर्सेंटेज वाढलं तर इट इज न्यूट्रलाइज्ड बाय दिस added OH minus ion reacts with this carbonic acid which is present, and it forms a bicarbonate ion and water. So the added base is neutralized. If acidic substance is added to blood, हा जो acidic substance add केला त्यांनी काय केलं? It gives excess of H plus ion. It combines with bicarbonate and it forms again back the H2CO3. That means because of presence of carbonic acid and bicarbonate, the buffer capacity of body fluid is increased, and because of that increased buffer capacity, pH of the body fluid is maintained in the specific range. This is the importance of carbonic buffer. Okay, the pH, secondly, this is the mechanism. Now what happens? Secondly, the pH of blood is 7.4, that you all know, is at upper limit of the buffering capacity of the system. म्हणजे ही जी सिस्टीम आहे याचा अप्पर लिमिट म्हणजे मॅक्झिमम याचा पीएच किती असू शकतो? तर 7.4 असू शकतो. अँड दिस 7.4 पीएच इज द अप्पर लिमिट ऑफ दिस बफर. म्हणजे त्याच्यापेक्षा तो जास्त होऊ शकणार नाही आणि तो 7च्या खाली जाणार नाही. ओके, अँड फॉर दिस रिझन दिस पीके इज or this percentage is decided in the body itself. It seems ill-suited and inefficient as many metabolic processes generate acid. मग आता याचा दुसरा पार्ट काय येतो की ब्लड मध्ये ठीक आहे, इट मेंटेन्स और इट इज व्हेरी हेल्पफुल टू मेंटेन पीएच ऑफ ब्लड इन प्रॉपर फॅशन. ओके, बट देर आर मेनी अदर प्रोसेसेस गोइंग ऑन योर बॉडी and there is a possibility of generation of acids or generation of bases in excess. So this this bicarbonate buffer or carbonate buffer is not sufficient for that. Okay, but we can regulate both CO2 and HCO3. पण हे जरी खरं असलं त्याच्यासाठी ऍक्सिस ऍडिशन साठी अजून वेगळे फॉस्फेट आहेत तुमच्या प्रोटीन मध्ये, अजून वेगळे बफर्स आहेत प्रोटीन्स मध्ये. अँड याचा जो सिग्निफिकन्स आहे दॅट सिग्निफिकन्स इज पर्टिक्युलरली विथ CO2 अँड HCO3 विच डिपेंड्स ऑन 3 इक्विलिब्रिया. कशावर तो डिपेंड करतो? तर CO2 फ्रॉम लंग्स it goes to blood. Okay, and this CO2 combines with water, it forms carbonic acid, and this carbonic acid in turn gives bicarbonate ion, and in this manner this balance is maintained. So in the carbonate buffer finally what is important is these 3 equilibria. कुठले 3 equilibria? तर कार्बन डायऑक्साईड आला ब्लड मधून लंग्स मध्ये किंवा लंग्स मधून ब्लड मध्ये, त्याचं कन्वर्शन कशात करायचं? इट इज कन्वर्टेड इनटू ऍसिड अँड इट इज कन्वर्टेड इनटू कार्बोनेट. सो बिकॉज ऑफ दिस 3 इक्विलिब्रिया the proper pH of blood is maintained by carbonate buffer. Okay, see, removal of carbon dioxide from blood helps to increase the pH. If you remove carbon dioxide, see, If you remove carbon dioxide, what will happen? It will form undissociated H2CO3. That means H plus ions will be removed. And removing of HCO3, if this is removed, HCO3 minus is removed from blood, it will हा जर रिमूव्ह केला तर नॅचरली काय होणार, H प्लस आयन्सचं कॉन्सन्ट्रेशन काय होणार, वाढेल. आणि H प्लस आयन्सचं कॉन्सन्ट्रेशन वाढलं की पीएच काय होणार, कमी होणार. आणि इन दिस मॅनर increase and decrease in pH of blood is maintained by carbonate buffer, which is responsible for proper pH of blood. Okay, I have given a picture here. Lungs remove carbon dioxide, kidney remove HCO3 minus, that is carbonic acid, sorry, bicarbonate, and heart rate hinders CO2 removal. तुमचं जेवढं पंपिंग जास्त होईल तेवढं ते काय करतं, हार्ट ऑक्सिजन घेतं, आणि जेवढं ऑक्सिजन जास्त घेतला जातो त्याच्यामुळे कार्बन डायऑक्साईडला प्रॉब्लेम येऊ शकतो, आणि तो प्रॉब्लेम या दोन्ही गोष्टींमुळे काय होतो, तुमचा सॉल्व्ह होतो. सो दिस टू ऑर्गन्स आर व्हेरी इम्पॉर्टंट. कुठले कुठले? लंग्स अँड किडनी. So this carbonate buffer is particularly important in lungs as well as in kidney, and these are responsible to maintain proper pH. Okay. आता या सगळ्या गोष्टी तुम्हाला, it is very difficult for you all to understand the physiology. If you read it repeatedly, you will get it. It is very simple, and it is also nicely explained in G.D. Christian's book. Okay. And remember, we are not biologists. आपल्याला काय biologyचे प्रश्न कोणी विचारणार नाही. But basic things which you have to know the proper functioning or physiology, it is very important to know these little things. So understand thoroughly and remember this, that bicarbonate buffers are very useful to maintain pH of blood. Okay? Is that fine? See, all are there. I'll wait for 5 minutes. Just revise the things. Open करा तुमचे सगळ्यांचे व्हिडिओ. हॅलो, पुढचा पार्ट आपण थोडा 1-2 मिनिटांनी बघू. आधी तुम्ही ओपन करा, मला समजून घेऊ देत काय. Applications of buffer. What are the important fields? बोला, माइक ऑन करा. कुठले कुठले fields important आहेत? Which are the fields which are important for buffers?
Biological system.
Okay, biology, physiology, then pharmacy, ophthalmology. Okay. You tell me, is it important in food industry? फूड इंडस्ट्री मध्ये बफर लागतात का? येस और नो?
Yes, ma'am.
येस. कुठे लागतात?
Preservative.
प्रिझर्वेटिव्ह. व्हेरी गुड. अजून कुठे बफर लागतात? See, the today's world is of nanotechnology, and to prepare nanoparticles of specific size. In most of the organic synthesis or nanoparticle synthesis, there are buffer is very important. Okay. When you carry out different titrations, it is very important for you to maintain pH proper. So you use ammonia buffer there. वापरता की नाही तुम्ही? काही ग्रॅव्हिमेट्री मध्ये वापरता, काही प्रिपरेशन्स मध्ये वापरता. So that is also true. मी तुम्हाला फिजिओलॉजीशी रिलेटेड सांगितले कारण आपल्या अभ्यासामध्ये कुठले आहेत, वी आर मोस्टली फोकसिंग ऑन बॉडी बफर्स. ओके, बॉडी बफर मध्ये सगळ्यात महत्वाचं काय, तर देर आर 3 टाइप्स ऑफ बफर्स, प्रोटीन, फॉस्फेट अँड कार्बोनेट. त्याच्यापैकी आज आपण कुठला बघितला, फक्त कार्बोनेट बफर बघितलं. मला माहिती आहे तुम्हाला थोडासा त्रास झाला असेल ते बघून चित्र, की अरे हे तर सगळं वेगळंच आहे, आमचं बायोलॉजी नव्हतं. बट रिमेंबर इट इज व्हेरी सिम्पल फिजिओलॉजी, अँड फॉर दिस रिझन you have to know this. Okay, so I'll coming back to again presentation. So this is carbonate buffer. So next is actually काय होतं, what is the functioning. मगाशी जे सांगितलं ते आता मी परत एकदा शब्दात सांगते. गॅशियस CO2 dissolves in blood to form carbonic acid. बघा इथे मी चित्र एक दिलेलं आहे. ऍक्टिव्ह CO टिश्यू अँड ऑर्गन्स, फ्युएल प्लस ऑक्सिजन, तुम्हाला एनर्जी मिळते. H2O प्लस CO2, हा जो CO2 तयार झालेला आहे तुमच्या शरीरामध्ये वेगवेगळ्या रिएक्शन्स मधून, दिस CO2 हा काय होतो, तर हा CO2 जो तयार झालेला आहे हा बाहेर जातो, आणि जो तुम्ही ऑक्सिजन घेतलेला आहे तो या पद्धतीनं जातो. आता या पद्धतीनं जाताना काय काय होतं बघा, द आउटसाइड एअर विच इज टेकन गोज टू लंग्स, लंग्स मधून ते आर्टरी मध्ये जाते, आर्टरी मध्ये ती ब्लड बरोबर असते. दॅट एअर दॅट इज ऑक्सिजन इज विथ ब्लड, दॅट इज हिमोग्लोबिन. त्या हिमोग्लोबिन मधून तो काय करतो, टिश्यू ऑर्गन्स मधनं फ्युएल घेतो, जे काय अन्न पदार्थ प्रोटीन वगैरे आपण खातो. इट कंबाइन्स, दॅट ऑक्सिजन कंबाइन्स विथ फ्युएल, इट प्रोड्युसेस वॉटर अँड CO2. आणि हा जो CO2 तयार झालाय हा CO2 परत पाण्याबरोबर येतो, तो H2CO3 फॉर्म करतो. दिस H2CO3 वेन्स मध्ये परत H+HCO3 फॉर्म करतो, जो परत H2CO3 होतो आणि तो परत CO2 बनून इथनं बाहेर टाकला जातो. फाईन, दिस इज द सायकल ऑफ O2CO2, दॅट इज द एअर वी इनटेक, इनहेल, एक्झेल. ओके, आत जाणारी हवा, बाहेर जाणारी हवा. आत जाणारी हवा ऑक्सिजन घेते, बाहेर जाणारी हवा कार्बन डायऑक्साइड सोडते. सो इन ब्रीथ, आउट ब्रीथ, exhale, inhale and exhale. So this CO2 which is present in blood forms carbonic acid, carbonic acid to bicarbonate, bicarbonate which is formed sped up by presence of enzyme कार्बोनिक अनहायड्रेट्स. बघा जेव्हा मल्टिपल चॉईसची तुमची टेस्ट येते तेव्हा या पद्धतीचे प्रश्न विचारले जातात. विच एन्झाइम इज रिस्पॉन्सिबल फॉर कन्व्हर्शन ऑफ कार्बन डायऑक्साइड टू कार्बोनिक ऍसिड इन ब्लड. ओके, विच एन्झाइम इज इट, कार्बोनिक अनहायड्रेट्स इन ब्लड is responsible for conversion of acid to bicarbonate, okay, or carbon dioxide to bicarbonate. Concentration of carbonic acid in blood is very low. बघा, if it is high, concentration high झालं की pH काय होणार, pH will turn low. If pH will turn low, what will happen, pH will low, and if pH will be low, what will happen, the blood pH will also change, and in order to maintain it constant, it is very important to have buffer there. It works in reverse as well. H plus ions is removed from cell by blood plasma. Okay, ते कमी पण होतात, ते वाढतात पण. It is neutralized by reaction with, हे जर वाढले तर काय होणार, it reacts with HCO3 minus and leads to release of CO2. काय होतं, CO2 release होतो, and it gas from lungs. It can also adjust breathing if you need to keep more H plus ion in the blood. So this is all physiology. Don't go into deep. Read it carefully afterwards. So this is finally what I should say is a great system because it can be readily regulated. So कोण regulate करतं? We only regulate. Okay, म्हणजे तुमचं जे श्वासाचं अंतर आहे हे, that this is in our hand. So it is very important to maintain that proper balance, and for this reason it is very important to what I should say, to गिव्ह युअर बॉडी अ स्पेसिफिक टाइप ऑफ एक्सरसाइज, ज्याला आपण काय म्हणतो, प्राणायाम म्हणतो. ओके, and that is very useful to maintain this O2 and CO2 balance in your body. If you regulate it in the morning, then this functioning will be proper. Okay, so this is the part of lungs, inhale and exhale. What happens in kidney? The kidney's functioning काय आणि kidney मध्ये काय, what are the proper ways to how kidney functions or how it maintains the pH? What happens in kidney? What if pH changes in blood? What is acidosis? What is alkalosis? This I will discuss in the next lecture. So this is all for today. Fine. Let me tell you or solve if there are any questions. Fine. सांगा काय क्वेश्चन्स आहेत. 10:40 झालेत. मी 11:45 ला तुम्हाला बंद करून थोडासा वेळ देणार आहे अभ्यासाला. क्वेश्चन्स बद्दल काय अडचण आहे का? म्हणजे एक्झाम बद्दल, क्वेश्चन्स म्हणजे एक्झाम बद्दल. हॅलो. नो, व्हेरी गुड. फक्त अनुपमलाच अडचण नाहीये. व्हॉट अबाउट अदर्स? व्हॉट अबाउट अदर 14 मेंबर्स? अफसाना?
नाही मॅम, नाहीये काय डाऊट.
नाहीये काही. ऑल सेट?
हा मॅम, सांगितलं मग चव्हाण सरांनी.
सांगितलं. वेर इज राज काकडे? There are only 15 members. I think you all are 17, 18. बरोबर आहे ना पाटील?
हो मॅम.
Okay.
Right.
So where are other two? Where are other two members?
मॅम राजचा काहीतरी प्रॉब्लेम झाला त्यामुळे मॅम तो लेक्चरला जरा येऊ शकत नाहीये.
अरे पण आता तुम्ही टेस्टला आलं पाहिजे ना, टेस्टचे तुमचे मार्क्स धरले जाणार आहेत.
हो त्याला सांगितलंय राजला तसं मॅम.
सर चव्हाण सरांनी सांगितलं असेल ना टेस्टच्या बद्दल?
हो हो सांगितलं मॅम.
ओके, काय अडचण नाही. थांबवायचं आपण. काय
हो
सांगितलं
मॅम.
तुम्हाला? टेस्ट अशीच कंटिन्यू सुरू होणार आहे का तुम्हाला ब्रेक देणार आहे ना थोडासा? व्हॉट आर द इन्स्ट्रक्शन्स फॉर टेस्ट?
टाइम टेबल आहे ना मॅम, तसंच असेल. 5 मिनिट्स ब्रेक मध्ये.
नाही नाही, पण तुम्ही किती वाजता लॉग इन व्हायचंय?
11:15
मॅम लिंक प्रोव्हाइड करणार.
लिंक दिलेली आहे, त्याच्यावर तुम्ही जाणार. ओके, नीलम जगताप पत्ता आली आहे. फाइन. So I'll stop here. Best of luck. Solve the questions. Enjoy your test. Fine.
थँक्यू मॅम.
थँक्यू मॅम.
करू बंद?
हो
In case
चालेल.
if you face any problem, discuss करा परत. हा,
येस
मी
मॅम.
आजचं लेक्चर मी टाकते परत, ते बघा.
थँक्यू मॅम.
ओके.